It's my pleasure to introduce for our final talk before we do break for lunch, Professor Hildebrandt Ruiz from the Department of Chemical Engineering at the University of Texas. I'm going to suspect that most of you do not know of the Health Effects Institute. The Health Effects Institute has been a jointly funded activity by the U.S. Environmental Protection Agency and the fuel supplying companies and automotive manufacturing companies for decades, studying the effects of emissions from vehicles on health. A few years ago, they started a new program that they've called HEI Energy, Health Effects Institute Energy, looking at unconventional oil and gas development. And their particular interest is health effects. And so what you'll hear about next is what we can learn from all the work we're doing on greenhouse gases that will be relevant in local communities for impacts of criteria air pollutants, hazardous air pollutants. And Professor Hildebrandt Ruiz is leading that effort for the HEI here. So, Leah.
Thank you for the introduction and for the invitation to speak here today. I recognize that I stand between you and lunch, so I'll try to keep this brief. But as Dr. Allen introduced, our work that I'll be talking about today is actually not focused on methane. So I'll be talking about this project in which we are developing tools to characterize emission of other energy pollutants in addition to greenhouse gases. So the general idea here is that oil and gas operations emit hazardous air pollutants in addition to greenhouse gases. Those pollutants pose major concerns for public health and for environmental justice. On a positive note, all of the work that all of you are doing in mitigating greenhouse gas emissions will have co-benefits of also mitigating the emissions of those hazardous air pollutants. And so what we're in the process of doing is to build upon models that were developed to characterize greenhouse gas emissions, to also predict emissions and dispersion of these other pollutants. A little bit more specifically, we are expanding the methane emissions estimation tool to include additional processes, as well as additional pollutants such as BTEX, other VOCs, NOx, and particulates. As Dr. Allen mentioned, this project is funded by the Health Effects Institute Energy, and it's a collaborative project. I'm showing here all of the principal investigators that are part of this project. Our expertise span a wide range between measurements and modeling, so we're doing measurement activities in addition to modeling, exposure modeling, public health, as well as biostatistics. And the photographs here are just the principal investigators of the work. We work with a large group of researchers, most of us at the University of Texas at Austin, and a large group of graduate students who are all working together on this project. So I was going to introduce the Health Effects Institute, but don't need to do that anymore. Just briefly, again, HEI Energy is a new affiliate of HEI, and this project that I'm talking about was actually part of their first call for proposals. And so I'll be talking about different classes of other pollutants that we're concerned about, and just want to give some examples about how much they can matter. This first pollutant I'll be talking about are NOx. NOx emissions from oil and gas operations and their impact on regional ozone. This project was led by a PhD student in our group, Mrinali Modi, and she has a poster out there that goes into much more detail on the project. I'll just be briefly kind of giving an overview of the project. This is a summary of NOx emissions in the Eagle Ford Shale region from oil and gas operations. The two biggest sources here are compressor engines and hydraulic fracturing engines, which, for example, are responsible for 15% of the NOx emissions in the Eagle Ford Shale. Within the Eagle Ford Shale, 25% of these hydraulic fracturing NOx emissions are from just one county, Karnes County. So the next analysis that I will present is focused on NOx emissions from hydraulic fracturing engines in Karnes County. And what we focused on here is the spatial and temporal distribution of those NOx emissions and how that impacts regional ozone formation. So in general, many emission inventories will report hydraulic fracturing NOx emissions as an annual average and a county average. And what we looked at here is the impact of distributing these NOx emissions differently and perhaps more realistically. So I'll compare two different cases. The poster out there actually has 4 different cases. But case 1 basically distributes the emissions evenly across all wells in the county and over all 365 days of the year. Case 3 aims to be perhaps a little bit more realistic by distributing the NOx emissions across only those wells that we know were fractured during the year, and also to assume that all of those NOx emissions due to hydraulic fracturing at that specific well occur over a 1-week period, which is a more realistic time frame over which hydraulic fracturing emissions occur. And so then what we looked at is the impact on regional ozone concentrations. And what's compared on this figure are the mean values of the daily maximum 8-hour average ozone concentrations, the MDA8 ozone concentrations. So this is a map here. The counties in the darker colors are the counties of the Eagle Ford Shale. This one here in red, if you can see the red, this is Karnes County. So again, the only thing we changed here is the spatial and temporal allocation of NOx emissions in just this county. And then the colors are the changes in the ozone concentrations. And so what we see in Karnes County, where the NOx emissions occur, we see a decrease in ozone concentrations due to the titration of ozone by NOx. And then downwind of Karnes County, so the predominant wind direction is from the southeast in this region. Downwind of Karnes County, we see what are really huge increases in the MDA8 values, exceeding 10 parts per billion in San Antonio and further downwind as well. So again, one example of another pollutant from oil and gas operations that is really important for regional air quality, and that we are working to be able to model the effects of. We are interested in a much larger suite of pollutants, including also, for example, volatile organic compounds, VOCs. And so for some of these pollutants, we are in need of additional measurements. And so I want to present just some measurements that we have been doing and will be doing more of. Again, we are focused on the Eagle Ford Shale at this point, even though the model that we are developing with the correct input data will be able to be applied to other regions as well. We are, for the measurements, also focused on Karnes County, which is in the middle of the Eagle Ford Shale, and has a really high density of production activity. That's why 25% of the NOx emissions are from that county, and also has a relatively high density of population. So also from the perspective of human health impacts, it's an area of concern. This is where our actual measurement location is. This is Karnes City, so this is at the edge of Karnes City, and our measurements here were co-located with the continuous air quality monitoring station from the TCQ. So we have different measurement platforms. We have instrumentation set up in what we call a permanent trailer. So that's just located stationary for several weeks, taking measurements for several weeks at the site. And we also have a mobile measurement trailer, which is a fully electric cargo van in which we put our instrumentation and can take measurements out of. So what that allows us to do is to drive around to get greater spatial coverage of our measurements, but also to get much closer to the sources. And one of the things we focused on in our first measurement campaign this spring was to characterize emissions from flaring activity. So this is an overview of some preliminary data. This is now a map of the region. So here's Karnes City, Kennedy, so some surrounding towns. And the third dimension here are concentrations. So what you can see here, basically, you can see is all the different locations where we drove, and then several plumes that we observed during our drives. And we just pointed out here some flares that we drove by. Again, it's a fully electric van, so we can also just be stationary for some time to sample those plumes. These are BTEX concentrations, so blue is benzene, and then red toluene and C8 aromatics, so the sum of xylenes and ethylbenzene are in the orange color. And just to put some numbers to these concentrations, I'm just going to show a quick time series of the flare 1 plume that we observed. So this is here on the right vertical axis, we are measuring methane concentrations. We do also measure methane concentrations. And you see this is really a huge plume here of 40 ppm of methane. I'll point out this is just a minute and a half of measurements. So we were located next to this flare. There must have been sort of a strong downdraft for us to be measuring these high concentrations. And then benzene concentrations as high as 300 ppb. So we can now take these data from the variety of measurements of different flares and repeat measurement of those flares to use those data to eventually include flaring emissions in the model. One other pollutant that I just want to point out, this is from a study we just published from measurements we took 2 years ago at the same site, is chlorine gas. So we saw some really high concentrations of chlorine at Cairns City, the highest inland concentrations reported to date. And briefly, chlorine will photolyze in the atmosphere to form chlorine atoms, which are really potent oxidants, more potent than the hydroxyl oxidants. So this is going to result in even higher concentrations of secondary pollutants, such as ozone. So briefly, to summarize, we are developing tools to evaluate other energy emissions in addition to greenhouse gases. Broadly, our focus is on pollutants of concern to human health. More specifically, we are expanding the MEAT model to include BTEX and other pollutants of concern to human health. We are also taking measurements to help characterize some of those emissions and then include them in the model. This final model will be a community model open to the community. It will be called Tracer for tracking community exposures and releases. This is also the name of the collaboration funded by HEI Energy. And here's my contact information. Please don't hesitate to reach out with questions. And if there's time for questions now, I'll answer them now too. Thank you.